Welcome to the DIY Honda Garage channel. The DTC B1225 refers to a diagnostic trouble code associated with the Honda Accord models from 2008 to 2012. This code specifically indicates an issue with the in-car temperature sensor circuit. The in-car temperature sensor is crucial for regulating the climate control systems within the vehicle, ensuring passenger comfort by providing accurate interior temperature readings. When there's an open in this circuit, the climate control unit may not function properly, leading to incorrect temperature adjustments. The diagnostic process is often initiated by using the Honda Diagnostic System, HDS, to read and clear codes. Failure to resolve the DTC can result in persistent operational issues with the interior climate control features, making it imperative for technicians to effectively troubleshoot and repair the root cause. The in-car temperature sensor plays a fundamental role in monitoring cabin air temperature, directly affecting how the HVAC system operates. It provides real-time temperature readings to the climate control unit, which subsequently adjusts the heating and air conditioning to maintain the desired temperature set by the occupants. In most Honda Accord models from 2008 to 2012, the in-car temperature sensor is typically located near the front interior section of the vehicle, often mounted in the dashboard or console area. If this sensor circuit has an open, it can lead to improper readings, causing the HVAC system to underperform or malfunction altogether. This can lead to discomfort for occupants due to inconsistent cabin temperatures. Knowing the specific location of the sensor is vital for effective troubleshooting, as technicians work through the diagnostic steps detailed for addressing DTC B1225. When diagnosing DTC B1225, a few key potential causes should be considered. One common issue is an open in the in-car temperature sensor circuit, which can happen due to damaged wires or poor connections. This open circuit prevents the temperature sensor from relaying accurate data to the climate control unit, leading to various HVAC issues. Another significant cause may be a faulty in-car temperature sensor itself. This sensor could be damaged or malfunctioning, directly impacting its temperature readings. Additionally, any wiring complications, such as frayed or broken wires, can also contribute to the problem, necessitating a thorough inspection of the wiring harnesses involved. Identifying the exact cause is critical for ensuring a successful repair and restoring proper function to the climate control system. The symptoms of DTC B1225 can manifest in various ways, impacting the overall vehicle climate control experience. One of the most noticeable signs is inaccurate temperature readings within the passenger cabin. This can result in the HVAC system either overcooling or overheating. Drivers may also experience malfunctions within the HVAC system itself, such as air blowing at an erratic temperature or failure to switch between heating and cooling modes effectively. Additionally, the illumination of the A and auto indicators on the dashboard may also serve as a direct warning sign pointing to this diagnostic code. These symptoms not only contribute to passenger discomfort, but can also lead to further issues if not addressed immediately, making it essential for technicians to respond to these warning signs as part of the repair process. The first step in troubleshooting DTC B1225 is to employ the Honda Diagnostic System, HDS, to clear the diagnostic trouble code. Clearing the DTC is vital, as it resets the vehicle's onboard computer and prepares the system for a fresh diagnostic session. Following this, it's important to turn the ignition switch to the lock, 0 position, and then back to the on, 2nd position. This step ensures that the vehicle's electrical systems are appropriately energized for the self-diagnostic function. The HDS also facilitates an accurate assessment of the vehicle's current condition post-clearance. This initial troubleshooting involves both software and hardware elements of the vehicle's diagnostic capabilities, setting the stage for more detailed troubleshooting as outlined in the subsequent steps. In this second step of the troubleshooting process, technicians will perform the self-diagnostic function using the HDS or through the climate control unit. This self-check is essential to identify any persistent issues that may not have resolved with the initial DTC clearing. After conducting this diagnosis, the next step is to check for DTCs to see if any codes reappear. If DTC B1225 or the A and auto indicators are displayed again, this signifies the need for further investigation into the in-car temperature sensor circuit. On the other hand, if no DTCs are indicated, this may suggest an intermittent failure, warranting a thorough inspection for loose wires or poor connections, which could also translate into similar symptoms affecting the climate control system. Having confirmed the presence of DTC B1225, the next step involves turning the ignition switch back to the lock 0 position to safely access the in-car temperature sensor. This step is crucial as it ensures all electrical systems are deactivated during the diagnostic process, thereby minimizing the risk of electrical shock or component damage. Once the ignition is in the lock position, the technician should carefully remove the in-car temperature sensor for further testing. This process should be handled with caution to prevent damage to the sensor or surrounding components. Removing the sensor allows for the next step in the troubleshooting process, which will involve testing the sensor's functionality to determine if it is operating correctly or requires replacement. Following the removal of the in-car temperature sensor, the technician must test its functionality to ascertain its operational status. This testing phase is critical because a malfunctioning sensor could be the primary cause of DTC B1225. Tests can involve measuring resistance and ensuring that the values fall within the specified range outlined in the vehicle's service manual. If the sensor is found to be in working order, it suggests that the issue may lie elsewhere in the circuit. However, if the sensor is defective, the technician would then proceed with replacing the in-car temperature sensor. Proper assessment ensures that all components related to the climate control system are accurately diagnosed, which is key in resolving the DTC efficiently. Once the in-car temperature sensor has been tested, the next troubleshooting step is to disconnect the climate control unit connectors A and B. This disconnection is essential as it prepares the system for continuity checks that will help identify any wiring issues affecting the in-car temperature sensor circuit. Specifically, technician attention will focus on climate control unit connector A, 28P, and connector B, 12P. Proper disconnection helps to isolate the sensors and connectors, eliminating potential interference during the continuity testing. Conducting these checks ensures that the circuits are intact and can relay accurate information between the components, vital for restoring the full functionality of the HVAC system. The next critical step involves checking for continuity between the climate control unit connector A, 28P terminal number 26, and the in-car temperature sensor 2P connector terminal number 1. Continuity refers to the ability of an electrical circuit to conduct a current. By ensuring continuity, technicians can confirm that electrical signal transmission is intact between the climate control unit and the temperature sensor. If there is continuity, this indicates that the wire between these 2 points is functioning as intended, and the issue may lie elsewhere. However, if continuity is absent, it would suggest an open in the wire, necessitating repairs to address the defect and restore the circuit. This step is essential for diagnosing circuit integrity and ensuring that the climate control systems function effectively. Following the continuity check from Climate Control Unit Connector A, technicians must then proceed to check for continuity between Climate Control Unit Connector B12P, terminal number 10, and in-car temperature sensor 2P, connector terminal number 2. This step verifies the continuity on a different part of the circuit, further isolating potential issues that may prevent the in-car temperature sensor from operating efficiently. Like before, the presence of continuity indicates that the wire is conducting properly and that the sensor should, theoretically, be working. Conversely, if continuity is not present, it implies another open in the circuit that needs to be fixed. This step is crucial for thorough circuit diagnostics, allowing for targeted repairs that can restore the climate control system to full functionality. Once all repairs have been performed related to DTC B1225, the final repair verification step is essential to ensure that the issues have been fully resolved. Technicians should check the overall operation of the climate control systems to confirm that they are functioning correctly and responsively to temperature adjustments made by the occupants. This includes evaluating whether air temperature matches the set levels on the control panel and noting any discrepancies. Additionally, it is crucial to verify that DTC B1225 has been cleared from the system to ensure that it does not reappear after repairs. This final step not only completes the troubleshooting process, but also serves to reassure the vehicle owner that their climate control systems are working as intended. Preventive maintenance plays a vital role in avoiding recurrence of issues, such as those associated with DTC B1225. Regularly checking the wiring harness surrounding the in-car temperature sensor can help prevent future problems caused by frayed or disconnected wires. Technicians should inspect these wires for any visible signs of wear, damage, or looseness, as they can significantly impact the system's functionality. Additionally, periodic inspections of the in-car temperature sensor itself can identify any early signs of malfunction. Keeping these components in good condition will enhance the reliability of the climate control system and ensure passenger comfort over time. This proactive approach can save vehicle owners time, money, and ensure a pleasant driving experience. In summary, DTC B1225 highlights a critical issue with the in-car temperature sensor circuit in the Honda Accord models from 2008 to 2012. Understanding the causes, such as open circuits or faulty sensors, allows technicians to effectively troubleshoot the problem. Conducting thorough checks of the climate control unit, the in-car temperature sensor, and associated wiring is essential for determining the correct repair path. Additionally, maintaining the system through routine inspections and proper testing can prevent the recurrence of similar issues. Following the outlined troubleshooting steps ensures that the vehicle's climate control systems function properly, which in turn enhances the overall driving experience for occupants. Please like and subscribe to the channel. See you next time.